All right. So we're going to talk about what is ontology. First, I want to make a point that everybody actually can be an ontologist as early as high schoolers, and especially for domain experts. You will benefit from this very intellectual and brain stimulating process of modeling a domain ontologically. I hope you would really will benefit from that and feel fun to enjoying this process. So I just want to make a little bit introduction for my journey to an ontologist. My training is in medicine and molecular immunology. I do not have any background of philosophy or computer science or data science when I did study, but I do like to learn things. When I graduated from my master degree, I actually went to a .com company in China, and I learned about website, and then I go to schools for just separately for learning SQL databases. And then after that, I went to do a PhD in medical informatics in Japan, while I need to build a database for organizing the susceptibility genetic factors for diabetes. Then I learned about ontology concept and I started self-learning. And then there was summer school in Spain for semantic engineering. That was 2008 or I, I think. I went there, so give me a little bit booster. But before that, before I going there, I already had a base of building ontologies. And then in my postdoc at the University of Michigan, I really did a lot of ontology work. So this is a cumulative learning process. So starting from the word ontology, the word ontology, it means a study of being. So just from the meaning of this is very philosophical, but then this philosophical ontology word then apply to the computer science, and we use it for a lot of usage building understanding of domain, which can be understood both by human and by machine. That is basically our keywords for ontology. So now, Chris, can you let me know who developed the first ontology in humankind? Because I cannot see you, please just speak up.
Aristotle.
Yes.
Seriously?
Yes, it is.
That's awesome.
Yeah. So yes, Aristotle, he is the father of logic, and he's a student and a colleague of Plato. And it is associated very closely with his question of being, qua being, the being of all entities in the wildest sense have in common. So I recommend if you have time, read this two link. One is about his categories. It's really very ontological, philosophical. And then read another link down is his life story. Okay, so this is what we are building now. This is an example of a coronavirus infectious disease ontology. So you can see you have different terms in the node and then link to another node. And the link we define using a relation to define. However, as part of Obo Foundry ontology, we don't just define anything freely. We mostly reuse the upper ontology for coherent definition. For example, as part has role, has certain definition, logical definition in the buffer or oboe that we use, so that this from the beginning, the ontology is interoperable with other oboe foundry ontology if they all use the same relations and define the terms in the same way. So here, different box has different edges because they have different classes. This is like a slice from hierarchical ontology in the like a slideshow. So the red ones are a process, the black ones are material entity, and the blue ones are raw quality or phenotypes, just to make a difference, which you will see that it is a kind of similar with a network. Some people will say, what's the difference with ontology and the network? So ontology has hierarchies. It is, if you think about it, it's more like a 3D. And ontology also defines links between nodes. I don't think network necessarily define links between nodes. They have certain kind of setting, probably if, maybe
Yeah,
Brad knows more.
this is like a knowledge graph. So a typical network map may not have those links, but a knowledge graph should.
Yeah.
So this is fascinating. Very cool.
Yeah, I'm going to talk about knowledge graph next. So
Perfect.
knowledge graph does, yes, knowledge, it looks like knowledge graph, but ontology has hierarchy, and then we have hierarchy tree view, horizontal network view. And knowledge graph definitely defines link between nodes. And ontology is kind of treated as a footprint of knowledge graphs, because as I said, that ontology follows certain rules for defining the relations and the terms using logic description to logically define the terms relationships. Knowledge graph sometimes is a little bit loose, but I think nowadays we don't make a lot of differences between knowledge graph and ontology. Ontology can be seen as a knowledge graph. But if you talk, once I went to this, I went to Saudi Arabia biohackathon, and we are talking about knowledge graph, and I said, for me, ontology is like knowledge graph, and multiple people told me no. So, yeah, I said yes, I know that they're different, but I know but it's kind of same. So okay, so now we come to the key hierarchy between ontologies. The concept that address hierarchy in ontology is subclass and class relationship. So here, the subclass A is, we use is a relation pointing from a subclass to a class, a mother class, we can say. So which means each instance of a subclass A must be an instance of subclass of the mother class B. So in this figure, we show that a car is a subclass, which is a vehicle. So everything that is an instance of a car must be everything must be the instance of vehicle. So there is an inheritance relationship here. There's no, when we define the subclass relationships in ontology, we always think, if I create this subclass, does the instance of this subclass always be the instance of the class that I want, the mother class that I want build into? So that this will be a important question always. And then, so what is an instance and property in a sense of ontology? So here, down here, I want to think about the question like, what is an instance in this figure, right? We have animal, we have cats, and we have zoo. So dog one is an animal, and cat is a cat, and cat is a subclass of animal. So cat one is also an animal. And cat 2 and zoo, they host a relationship of a zoo host the cat relationship. So this is I should put a citation here. This is from the wiki on RDF. Can you please let me know what are the instances in this figure? No? Mm.
Is the animal?
Instance, okay. Instance is dog 1, cat 2, and the zoo 1 is actually also instance. So the concept, so the classes are very, if you think about it, is a very abstract concept, like a cat. When you think about a cat, I'm thinking about my own cat, Riley and Minnie. I'm not, but when we talk about cat, we are just talking about cat in general, unless I say my cat, Riley, that I'm specifically talking about this cat. But when we build the ontology, we say cat is a subclass of animal. So there is no nothing concrete in the word is animal, similar as a cat. So cat 1, cat 2 is a subclass. Dog 1 is is an instance, and the dog 1, if we put a class there, is a dog, right? Dog 1 is an instance of dog, and the dog is a subclass of animal, because dog is a subclass of animal. So all the instance of dog will be also an instance of animal. Therefore, they have this RDF type relationship here. And then the relationship hold between the zoo and the cat 2 is a relationship between the instances. Sometimes when you create classes, if I say zoo host cat on the class level, we have to make sure that that is true for all the instances. For all the instances of those classes. So zoo class host zoo cat is not true, because not all the cats are hosted in the zoo, and not all the zoo has cat. But if one zoo has a cat two in the reality, then you can build this relationship. So you have sometimes when we build ontologies, we have to think of that as well. Building relationships.
So in this case, like zoo is a class, animal subclass, and all those animals in the like
No,
dog, cat are instance, right? And
yeah,
sub
zoo.
and cat has many types of cat. So that will be like cat 1, cat 2, cat 3, or whatever those will be properties.
No.
So like class is the biggest, subclass smaller, like
Yeah.
is that correct?
Yeah. So no. The cat
Mm-hmm.
1
Mm-hmm.
is representing my cat,
Mm-hmm.
Riley. Cat 2 representing maybe another cat, which is
Different types of cat, like different types, but still cat, still the same instance, right?
so instance.
Uh-huh.
Okay. So instance is something that pointing to a real thing that I'm talking about the sense in a basic formal ontology sense.
Okay.
So instance is a real uh thing that initiated in this world. Like I have my own cat. I have my 2 cats, Riley and Minnie. They are existing in this world. So when I mention these 2 cats, they are instance. But when I mention about cat in the word, I use a class cat. The cat class is an abstract concept. Oh, yeah. So therefore, is a class in the ontology. And the
What
cat is a subclass of animal.
And the zoo is the class. So the biggest
No,
is the
yeah,
zoo.
zoo
Have zoo.
here.
Uh-huh.
Yeah, here I don't have a class for zoo. I only, in my figure, I only have a zoo one.
Uh-huh.
Zoo one is a instance.
Oh, okay. So zoo one
Yeah.
is instant. I
It's
thought
like
zoo one
maybe
is
let's say
class.
zoo, yeah, let's say zoo one is a zoo in DC. That zoo in DC, and cat two is a cat that you can find in the zoo in DC. It's a real cat. It's not a class cat because not all the cats in the world, not all the zoo in the world host all the cats in the world.
Mm-hmm. So and
So,
then what is the property here? It's like 1, 2, 3.
oh, the property. Okay. So property means the links between the nodes. Property. I didn't in this figure I mentioned about property, but I actually didn't define what is property. Yeah. So property maybe I can talk about next time.
Mm-hmm.
Yeah.
Okay.
So that's all. Maybe it's too jumpy, but I hope you can you can just design a little like concept map for anything that you feel you have a little interest or you're passionate about. You can create something like this. Okay, something like this. You don't need to. You could put on some statement on what you think the subclass and class and the instances are, but it's not required.
Is it has to be in real in the real world, or it can be created based on our category?
Oh, whatever you can do. Yeah, that is the end of my session. Let me know. Do you have any questions before we end? No?
Can I go back to that vesicle again? To that
Which one?
slide? I think I didn't write down what is that slide number. The vesicle.